This is about using of generative AI to produce rotor profiles, which are normally, as a standard, they are produced by numerical methods on using gearing theory. And what we did in here, we used, as you know, for AI, it is necessary to have a database based on which this neural network will learn and then produce something. So we created this database by creating the rack of the profile, whatever it is, we can talk about that, and then creating a series of normalized racks, about 60,000 in this case, using one type of a profile, which is called the demonstrator profile, free demonstrator profile, and then feeding this into this GAN network, and then when it generates a profile, returning it back to the rack, then it generates a new rack, returning it back and recreating a profile based on that. And then we did assess it based on the efficiency of the profile in terms of the capacity of the profile, but also leakages that this profile creates. And this is how it develops. So this is how the neural network develops this project. It's just an animation of how the space is working. And then this is just an example of how many, 3 out of 60,000 that we produce, how they look like. And then evaluated. And then what we realized in here is that some of these profiles, although they are based on a limited set of data, they produce better results. You can see here better results than the original profiles. So that gave us confidence to go further. And then Halil is now in this new project introducing physics-based GAN networks, so that this GAN network didn't look into physics of the problem, but physics-based GAN network to develop that later on. And just to mention Hamid, because he was very kind to come today, I didn't ask them to come. They come on their own. So his project is about selecting materials for water-injected compressors. And he has 3 phases in his project. The first one is to look into materials that may have been used in the past, but also new materials that exist. Because in compressors, we use materials that we used about 150 years ago as well. It's not changed much, and it is mostly because available manufacturing techniques and cost of this. So the first one is selecting materials. The second one is looking into different materials for two rotors, because that's also not common in industry. And we believe that two rotors, they have different function in twin screw compressors. So they may have different materials as well. And then validating that. And these are about 50, how many? 50? 51 materials that are selected from different steels, cast irons, and aluminum that he is now evaluating through his design matrix or decision matrix that he has made. And decision matrix is not based just on the technical aspects, but also on economy aspects of all. So with this, I would like to finish just summarizing. Project Secret really gave us an opportunity to work on these oil-free machines. And we believe that they will be implemented in especially high temperature heat pumps and hydrogen, but also other refrigeration systems, because oil actually is not helping refrigeration system. It's helping compressor to work in the refrigeration system, but refrigeration systems suffer because of oil, because oil remains in the parts where you don't want it to be, and it also changes the flushing of the fluid. It affects that. So there are many things. So that's what we are looking for. And then AI, which is the main topic of our Project Secret second phase, which is extended, so it will be 10 years. AI implementation of IoT and looking into quantum computing, that's what we are going to